Sleeping under 6 hours is often treated as a harmless compromise, a small trade for productivity, entertainment, or unfinished work. But neurologically, the brain does not interpret it as a compromise. It interprets it as insufficient maintenance. Each night, your brain enters a highly organized repair cycle. Neural pathways reset, chemical balances stabilize, and energy stores are quietly restored. When sleep is shortened, this cycle becomes incomplete, and the brain is forced to operate without full recovery. What makes this especially concerning is how subtle the effects appear at first. After several short nights, brain imaging shows reduced activity in the prefrontal cortex, the region responsible for judgment, attention, and emotional regulation. You may still feel capable, yet your reaction time slows, focus drifts, and risk assessment weakens. More unsettling is this: sleep-deprived brains often lose the ability to recognize their own impairment. In clinical settings, participants performing poorly on cognitive tests frequently rated their performance as a normal. As one sleep researcher noted, the greatest danger of sleep loss is that the brain becomes a poor judge of itself, but reduced alertness is only the visible layer. Because while you are awake, metabolic byproducts continue accumulating inside the brain, substances that are normally cleared during deep sleep. And when that cleaning process is shortened, neurologists begin to pay close attention. Because what the brain fails to remove overnight may matter far more than feeling tired the next day. Deep inside the brain exists a maintenance network most people have never heard of: the glymphatic system. It activates primarily during deep sleep, not light rest, not drifting in and out. True, slow-wave sleep. When this phase begins, brain cells subtly contract, creating microscopic space between neurons. Cerebrospinal fluid then moves through this space, washing across brain tissue in a slow, deliberate current. Its purpose is straightforward: remove metabolic waste that accumulates during waking hours. Among that waste is a protein called beta amyloid, a naturally produced substance that, in excess, has been strongly associated with Alzheimer's disease. Under healthy sleep conditions, much of this protein is cleared nightly. But research shows that even a single night of restricted sleep can leave measurably higher levels behind. Not catastrophic, but not insignificant either. Think of it less like immediate damage and more like allowing dust to settle in a room that is normally cleaned every night. Miss one cleaning, little changes. Miss many, accumulation begins. Neurologists do not claim that short sleep directly causes neurodegenerative disease. The relationship is more complex than that. What concerns them is the long-term pattern, because the brain depends on repetition, night after night of clearance, to maintain its internal environment. When sleep consistently falls below 6 hours, that rhythm is disrupted, and the brain must continue functioning in a space that is gradually less pristine than it was designed to be. But waste buildup is only one consequence. Researchers began noticing another change in sleep-restricted brains, one that people often feel before they understand it. Emotional reactions intensify, patience shortens, stress responses rise faster than expected. The shift is not imagined, it is biological, and it begins in one of the brain's most ancient survival centers. Because when sleep drops, the emotional brain stops behaving rationally, sometimes overnight. One of the earliest neurological shifts caused by short sleep does not appear in memory tests or attention scans. It appears in your emotional stability. Brain imaging studies reveal that after restricted sleep, the amygdala, the brain's threat detection center, becomes significantly more reactive. In some controlled experiments, its response to negative stimuli increased by over 50%. This means the brain begins interpreting situations through a heightened survival lens. Neutral expressions can feel unfriendly. Minor problems feel urgent. Ordinary stress feels amplified. But the deeper issue is not the emotional surge itself. It is what stops regulating it. Under normal sleep conditions, the prefrontal cortex maintains a steady top-down connection with the amygdala, acting almost like a neurological braking system. It helps you pause, interpret context, and respond rather than react. With shortened sleep, that connection weakens. Not severed, just less coordinated. The result is a brain that becomes slightly more primitive in its responses, more reflexive, less measured. A sleep physician once described this state succinctly: The sleep-deprived brain is neurologically closer to survival mode than reasoning mode. You may recognize the outward signs: irritability that feels disproportionate, reduced patience, sharper emotional swings, quicker frustration. What makes this shift notable is how rapidly it can emerge, sometimes after just 1 or 2 restricted nights. Yet emotional volatility is still not the change that concerns neuroscientists most, because while mood fluctuations are noticeable, another effect develops more quietly. It interferes with the very process that allows you to learn, retain information, and think clearly the next day. And when that system is shortened repeatedly, the brain's ability to store new memories begins to falter, not dramatically, but enough that specialists immediately recognize the pattern, because sleep is not simply rest for the mind. It is when memories are physically stabilized inside the brain. And under 6 hours, that stabilization becomes unreliable. Throughout the day, your brain collects enormous amounts of information: conversations, decisions, names, patterns, small details you barely notice. But none of these are truly stable yet. They are temporarily held inside a structure called the hippocampus, which functions almost like a neurological holding space. Real storage happens later. During deeper stages of sleep, the brain quietly transfers important information from the hippocampus to long-term cortical networks, a process neuroscientists refer to as memory consolidation. It is less like saving a file and more like carefully rewiring the brain. When sleep drops below 6 hours, this transfer window shortens. The hippocampus remains partially loaded, leaving less capacity to absorb new information the following day. The result is subtle but familiar: reading the same paragraph repeatedly, forgetting why you entered a room, struggling to recall recent conversations, slower mental processing, not because intelligence has declined, but because the brain never received enough time to stabilize what it learned. Sleep researcher Matthew Walker, sleep scientist, once summarized the issue plainly: sleep is the single most effective thing we can do to reset our brain and prepare it for learning. What makes this especially important is that the brain does not simply catch up by trying harder. Attention alone cannot replace the biological work that occurs during sleep. Yet, even memory disruption is not the development physicians monitor most closely, because after repeated short nights, the brain begins drifting into brief, uncontrolled shutdowns. Moments so fast, many people never realize they occurred. And when they happen at the wrong time, the consequences can escalate quickly. Because the brain has a protective response when it becomes too deprived, it forces sleep, whether you intend to or not. When sleep debt deepens, the brain does something both protective and quietly dangerous. It begins triggering microsleeps, brief neurological shutdowns lasting anywhere from a fraction of a second to several seconds. You do not choose them. You rarely notice them. From the outside, your eyes may remain open, your posture unchanged. But for that moment, portions of the brain simply go offline. Researchers observing sleep-restricted individuals have recorded sudden lapses in attention even while subjects believed they were fully alert. One neurologist described it this way: when the brain is pushed past its sleep limit, it stops asking permission. These episodes become especially concerning during activities that demand continuous awareness: driving, operating machinery, or making rapid decisions. A few lost seconds can pass without memory, leaving only a gap in perception. What makes microsleeps particularly deceptive is that stimulation cannot reliably prevent them. Fresh air, louder music, even caffeine may increase alertness temporarily, but they do not eliminate the underlying neurological pressure. The brain still claims its moment. And as sleep continues to shorten night after night, another biological system begins to destabilize, one that governs nearly every function in the body: your internal clock. Because sleep is not only about duration, it is about time. And when that timing starts to drift, the brain no longer knows precisely when to release hormones, regulate temperature, or prepare you for restorative rest. The disruption reaches further than most people expect. Because once the brain's circadian rhythm begins to lose alignment, the effects are no longer limited to feeling tired. The most serious effects of sleeping under 6 hours rarely appear after one night. They emerge gradually when the brain stops treating short sleep as an exception and starts adapting to it as a pattern. At that point, neurologists begin describing the brain as operating under chronic sleep restriction. a state closely tied to disruption of the circadian rhythm, the internal timing system that coordinates sleep, hormone release, metabolism, and cognitive readiness. When this rhythm becomes unstable, the brain's predictive ability weakens. It no longer prepares the body efficiently for periods of alertness and recovery. Instead, it remains slightly misaligned, day after day. One hormone particularly sensitive to this shift is cortisol, often associated with the body's stress response. Under healthy sleep conditions, cortisol rises and falls in a controlled daily arc. With restricted sleep, that pattern can flatten or spike unpredictably. The result is not always dramatic. More often, it feels like a persistent mental heaviness, slower cognitive clarity, reduced mental endurance, difficulty sustaining attention, a background sense of strained sleep. Specialists sometimes refer to this as a functional wakefulness. You are awake. You are performing, but the brain is operating below its intended capacity. What makes this state notable is how easily it becomes normalized. Humans are remarkably adaptable, even to suboptimal biology. Many people living on short sleep report feeling used to it, unaware that sharper cognition and emotional steadiness are still biologically available to them. The brain, however, never stops signaling its preference. Given sufficient opportunity, it consistently moves toward longer, more structured sleep, because restoration is not a luxury for the brain. It is a requirement. The reassuring reality is that the brain is also highly responsive to recovery. When consistent, adequate sleep returns, many of these functional changes begin to recalibrate, not overnight, but reliably. Which leads to a quiet conclusion often shared in sleep medicine. Sleep is less about escaping the day and more about preserving the brain that carries you through it. And once you understand what unfolds beneath the surface each night, the question shifts naturally from a can I function on less sleep to something far more important. What level of brain function am I willing to live without?